Good afternoon, welcome everyone. Today we are going to discuss how to create data pipelines using essentially open source technologies. And we are going to discuss some of the technologies sponsored by Red Hat, right? So we are going to discuss mainly Strimzi, also Divisium, and also Epicurious Registry, and how those different tools help you build an event-driven architecture. First, we are going to do some introductions. So, Chris, if you would like.
Yeah, sure. So my name is Chris Cranford. I'm a principal software engineer at Red Hat. I've been there about 7.5 years. I primarily focus on change data capture with Divisium, but I do also contribute to Hibernate and to Quarkus projects as well.
Thank you very much. And I'm Carlos Arnal. I'm also a software engineer for Red Hat. I work mainly on Epicurious Registry. That is a runtime registry for both APIs and schemas. And I'm also a Quarkus active committer. So, first of all, let's discuss the agenda we have for today. We are going to discuss the different pipelines we chosen for our data pipeline, right? So, how they help you to build your event-driven architecture, and the benefits, the pros, the cons they have. Then we will do a step-by-step walkthrough demo using all the technologies I mentioned, like Strimzi, Divisium, and Epicurious Registry. All those tools are open source. And then finally, we'll do a wrap-up, and we will open the floor for any questions you may have, and we will share any potential thoughts we might have at the end. Okay? So here you can see the diagram of the architecture we are going to use for the demo. Essentially, we are going to have everything is going to start with a PostgreSQL database. We are going to use the Divisium PostgreSQL connector to capture the changes in that PostgreSQL database. We are going to stream those changes into Kafka using the serialization technology that is powered by Epicurious Registry. All that information is going to be serialized using the Abro binary format. And we will also have the Kafka UI. The Kafka UI, for those who are not really familiar with what it does, you can see the topics you have in your Kafka cluster. You can see the schemas that are present in the schema registry, and you can also see the messages that are actually written to the Kafka topic. Okay? For this demonstration, we need the Kafka cluster, and we also need the Connect cluster, right? So for having those, we are going to use Strimzi. Strimzi allows you to run the Kafka cluster, and it also allows you to run the Connect cluster, the runtime Connect, right? And then we are going to stream the changes that are published into Kafka coming from the PostgreSQL database. Using the Elasticsearch connector, we are going to sync those changes to Elasticsearch and to build a search index. Now, I'm going to start with the live demo. For those who want to go to have more information, here you have a QR code where you can scan that, and it's going to take you to the GitHub repository we're going to use for the presentation. Sorry, last minute issues. So, for the demo, because of the time constraints, we have mostly all the components deployed, right? So we have the Kafka cluster deployed, we have the Connect cluster deployed, we have a Epicurious Registry, we have the PostgreSQL database, and we also have Elasticsearch already deployed. So essentially, we have everything deployed except for the source connector that is going to capture the changes from the PostgreSQL database, and the sync connector that is going to take the changes in Kafka, and it's going to build the search index. Mainly, for simplicity, there won't be any aggregations or any transformations to that data. This is a relatively simple demo, but it's a realistic one, okay? So, first of all, what I'm going to do is essentially to deploy the source connector, okay? That is going to capture essentially the changes from the PostgreSQL database, and it's going to make them available in Kafka. So this OC apply is going to create the source connector that is going to capture the changes from the PostgreSQL database. I'm already in the connector directory. Yeah. Yeah. Okay, great. Now, If I go back to the OpenShift console, actually, I want the other. If I go to the operators, because Strimzi is an operator that allows you to run Kafka, right? So if I go to the Strimzi part, if I go to the Kafka connector part, now there is a new connector that has been created. We can see that the new connector is already ready, right? So the connector is already capturing all the changes from the PostgreSQL database and making them available in Kafka using the serialization technology we discussed. Now, if I go to the UI for Apache Kafka, I can see it's already updated. I can see that a bunch of new topics have been created, okay? Now, if I click on one of those topics, and then I go to the messages, you can see that there is some information already available in here, right? So, what's this? What's going on here? If I just try to deserialize this using a string, you can see that there is a bunch of strange characters, weird characters, right? That is because, as I said, this is using the Avro binary format. Now, if I change it to get the schema from the schema registry, you can see that now I can pre-visualize and I can preview the information that is in the message. Not only that, but here you have all the information about the value, the key shared is coming from the schema registry, and I can deserialize and see all the information, right? And if I go to the schema registry tab, I can see that for the database structure, the schemas have been created for both the key and the value. So for instance, if I check the product value, I can see that a new Avro schema has been created in the schema registry. So now I have captured all that I have in the PostgreSQL database, everything is in the Kafka UI, and I can check everything. And from here, Chris is going to take the rest of the demonstration.
Sure. Thanks, Carlos. One thing I want to point out here is that normally this particular UI is only compatible with Confluent schema registry. With the Epicurio schema registry, you can set some compatibility flags, and that's how we're able to make this work. So it really kind of shines to show the fact that you can drop in Epicurio as a drop-in replacement for Confluent's schema registry. So now that we have this data over into our Kafka UI, as we were looking at in our topics, we need to be able to get this information into our sync connector and into our Elasticsearch database. So I'm going to jump into a terminal here real quickly, and I'm going to apply our sync connector here. And what this is going to do is this is going to start up 5 different sync connectors. Now, with the Elasticsearch sync connector, unfortunately, you can't multiplex. It's a one-to-one mapping, so that's the reason why that we are deploying 5 different connectors, one for each of those topics that we have propagated changes in from our Postgres database. And we've done that propagation using initial snapshots. Now, if I jump over into Elastic View here, and I apologize for changing between white and black backgrounds. Unfortunately, we can't change that on this app. If I refresh here my indices tab, we should see that we now have these 5 indices that have been created in Elasticsearch. And as Carlos had pointed out, if we jump into our customers index, we can see that we have exactly the same values that we had in Kafka UI. So at this point, we have a full end-to-end integration with our snapshot data. And it was really, really simple, right? Just deploying 2 connectors on top of Kafka Connect. Now what we want to do, and while getting this snapshot data into our sync environment is great, we need to be able to also stream like those real-time changes. So let's jump into our Postgres database here. And what I want to do is demonstrate exactly how easy that is for you to do. So I'm going to cheat. I'm going to go to my cheat sheet here. I'm going to cut and paste this particular thing. Oh, terminal closed. Just a second. There we go. And I'm going to commit this. And if I jump really quickly back over into our Kafka UI, jump into our customers topic here, and go into messages, and I change this back to schema registry, we can see that this new record with ID 1005 is already there. It was really, really quick. Low latency is really, really important for a lot of applications, and that is one of the best things about using change data captures. You can get those change events from your source into your sync really, really fast. If I now search again here on my search index, we can see that I have added 1005 to the search index. Now, I want to show how important it is for us to get updates and talk about some of the changes with updates. So if I go back into my Postgres, jump into my cheat sheet here, I'm going to change the email address on this particular record. But before I commit this change, I really want to illustrate how fast this really works. So instead, what I'm going to do is I'm going to jump immediately into Elasticsearch rather than going into Kafka UI. So I'm going to commit this. I'm going to come back over here. I'm going to resubmit my search. And we're going to see that the email address for the record 1005 has already been updated. The low latency effect of getting these changes into a sync connector is really, really important, as I said before. If I go into my Kafka UI here and I resubmit, I'm going to see I now have a new event here in Kafka UI. One thing I want to point out with these particular events is that when you are getting these change events out of Debezium, normally your organization, you're not going to have just one database, right? You may have multiple different types of databases. You may have some Oracle, you may have some SQL Server, some MySQL, whatever the case may be. One of the benefits to using Debezium in change data capture is the fact that we unify all of these change events. So we don't care where it's coming from, what the source is, what you get as an output as a change event, all looks exactly the same. And this can be really, really important if you are building streaming applications or you have a particular consumer that you want to stream changes from multiple producers into a single consumer. You have the ability using Debezium to be able to do that with a uniform format. And if we take a look specifically at this format, we can see here in this particular event, this is my create event, that there is no before state, there is after state because it's an insert. And you can tell that this is a particular insert because if I scroll down here, the opcode here is C. Similarly, if I take a look at the update that we just performed, I would see something quite similar, right? I'm going to see that there is some before state, there is some after state, and then additionally, we're going to have an opcode here that tells us that it was an update. So these events give you a lot of information, but not only do we tell you what is the state changes that took place, but we also have the ability in the source info block to tell you exactly where in that particular database and what particular segment or transaction log that event took place. And in some of our connectors, we could even give you the SQL that generated that change event, which might be useful in some use cases. So to kind of wrap this up a little bit, to go full circle, let's go ahead and I'm going to cheat again. I'm going to grab my delete here. I'm going to jump into my terminal. And I'm just going to paste this in. I'm going to go ahead and commit this. If we jump back into Kafka UI here, I'm going to scroll right up, and I'm going to resubmit this. We can see we have two new events. And this is what we expect if you just deploy a Debezium source connector with the default configuration. You're going to see that there is this delete event. If we expand this and take a look, we can see that we have this source info block, this before block with the information that took place before the change event. The delete occurred. We have the after section that's represented here with null because there is no data that occurred after the delete. And similarly, if we scroll down just a little bit, we can see that there is a delete operation. And finally, there is this tombstone event. So this allows you, if you have compaction set up on your particular topic, this will go ahead and trigger the compaction for that particular key inside of Kafka. And finally, if we jump over into Elasticsearch and just requery this particular index, we can see that it's gone. And that's what we kind of expect. So creating these pipelines between a source and sync using Kafka Connect, using Strimzi, using Debezium, using Epicureo, and all of these open source projects, all on top of Kubernetes, is really, really simple and easy to use. And with that, I'm going to jump back into our slides here. And we have a little treat for you guys. I know that this is like the last day and it's the 11th hour, and we very much appreciate all of you guys coming to our event today. We have a raffle here giving away a pair of Bose noise-canceling headphones. If you guys can scan this QR code, it'll ask you a couple of questions, and you can enter into when those headphones. You'll be contacted through email to know whether or not you won. And with that, folks, I think you guys for your time today. If I need to, I'll put the QR code back up for those of you that didn't get it in time, and we'll open it up for questions.